Hey folks, welcome to my channel number 10. So there we have the problem on our screen. Integrate the following with respect to x. X plus 5 the whole power 6. So like in differential calculus, the idea behind solving these problems here is to reduce the particular expression that's been given to us into a much simpler expression and see if we can, apply one of the derivatives that we have learned under first principles, right? So let's go about doing these problems by the method of substitution. So, what is that substitution that will enable us to simplify this expression? And remember, folks, here, whenever it comes to integration, we are trying to find out the antiderivative, right? So, what we have been given is not your usual y, but you've been given dy by dx, and you've been asked to find x plus y the whole power 6. The reason I'm always relating it to differential calculus is both of them, the derivative and the antiderivative, are nothing but inverse functions, right? So I want you to go back and revise all the derivatives that you learned in first principles if you want to be solving problems in integral calculus, because they are very, very, very related to each other, right? So when you have dy by dx equals to x plus 5 the whole power 6, and you've been asked to find y, what is y represented as? Y is represented using the integral symbol, and the way to write this is x plus 5 the whole power 6 times dx, right? So how do we go about finding what is our y, right? And I want you to learn the method of substitution. And if you've not looked at my previous videos, I've done multiple problems solving derivatives using substitution method, right? So this works in a very similar method, just that we are finding the antiderivative. So what is that substitution that will make y to a much simpler expression, right? So t equals x plus 5. Let me say t. I differentiate on either side, right? Which means my dt by dx equal to d by dx of x plus 5, which is 1 plus 0, right? Because d by dx of x is 1. That leaves me with dt equals dx, right? Because my dt by dx equal to 1. Now I go back to my y and I'm going to represent everything in the form of t, right? And how do I do that now? Again, use the integral symbol. And now that my x plus 5 is t, right? And then I have t to the power 6 now. And then I have my dx, which is nothing but equal to dt, right? So this is integral of t to the power 6 dt, right? And I want you to recall that my d by dx, we have done this in our first video under integral calculus. And when I replace my n by an n plus 1, I get d by dx of x to the power n plus 1 is nothing but n plus 1 times x to the power n, right? Which means my antiderivative of x to the power n, which is, let me highlight it in, say, a particular color, right? X to the power n is nothing but x to the power n plus 1 divided by n plus 1 plus c. I have my constant, right? Because one particular function can have multiple antiderivatives, because dy dx of a constant is 0. And I apply the same formula here above. And what is my answer? E to the power 6 dt integral of that would be t to the power 7 divided by 7 plus c, right? And I know that, like in differential calculus, I cannot leave my final answer in terms of t. I'll have to put back everything in terms of x. And what is my t in terms of x? It is nothing but x plus 5, right? So my final answer is x plus 5 the whole power 7 divided by 7 plus c. right? So let's highlight it in pink. So there we have the final answer for this particular problem. X plus phi the whole power 7 divided by 7 plus c. I hope you found this content useful. Please do subscribe to my channel and support.